Assalamualaikum warahmatullahi wabarakatuh. Now we will discuss about the third application of redox reactions, which is displacement of halogen from its halide solution. Do you still remember what is halogen? It is a molecule comes from group 17 in periodic table. We have learned about halogen during our chemistry form 4 lesson. To discuss about displacement of halogen from its halide solution, we need to know the basic concept of halogen and halide ion. Halogen is the elements or diatomic molecule comes from group 17 elements, while halide ion is the ions formed from the group 17 elements. If we look at the series here, started with fluorine, chlorine, bromine, iodine, and astatine, we see that the more reactive halogen has higher ability to accept electron. Therefore, the higher position halogens are a stronger oxidizing agent. On the other hand, the lower the position of halide ion in group 17, such as astatine and iodide ion, astatide ion, and iodide ion, it has higher ability to release an electron. This makes the bottom halide ions are a stronger reducing agent. Now let us make some revisions on halogen. We know that going down the group from fluorine to astatine, the atomic size of group 17 elements increases. When the size increases, the distance between the nucleus of the atom and the outermost shells become further. It is harder for the bigger atomic size elements to accept electron into the outermost shell. We know that group 17 elements have to attract electron into the outermost shell in order to achieve the stable octet electron arrangement. That is why halogen becomes more difficult to receive electrons when going down the group. Therefore, the strength of this halogen as oxidizing agent decreases. This is one of the reasons why does the reactivity of halogen decreases when going down the group. Conversely, it is easier for the halide ion, such as astatide or iodide, to release their electron. The strength of halide ion as a reducing agent increases when going down the group. How does the displacement of halogens from its halide ions occur? Let us see this first example. In this experiment, chlorine water is added drop by drop into potassium bromide solution. Noted that in potassium bromide, there are presence of bromide ion, while in chlorine water, there are presence of chlorine molecule. If we refer to the series in the slide before, chlorine situated above bromine in the group 17 element series. Chlorine is more reactive halogen because chlorine has higher ability to receive electron, while bromide ion is the lower position ions in halide series. Bromide ion has higher ability to release electron. What happens during these reactions? Bromide ion will release electron to form bromine molecule. 2 bromide ion release 2 electron. Bromide ion will undergo oxidation reaction. Bromide ion is said to be a reducing agent. What happens to the chlorine molecule? As I said before, chlorine is a better oxidizing agent. Therefore, chlorine molecule will receive electrons to form a chloride ion. To balance the equation, we will produce 2 chloride ion, while chlorine molecule will receive 2 electrons. Chlorine molecule undergoes reduction. Chlorine molecule is said to be oxidizing agent. We have explained the redox reactions using a transfer of electrons. How about the changes in oxidation number? If we look at the half equation for the oxidation number of bromine in bromide ion changes from -1 to 0. The oxidation number increases. It confirms the oxidation reaction. While if we refer to the half equation for reduction reaction, the oxidation number of chlorine molecule is 0 and then decreases to -1. Okay, it is confirmed that chlorine molecule undergoes reduction. Now, let us watch the animation of this experiment. When chlorine water added to potassium bromide solution, noted that potassium bromide solution is colorless, while chlorine water is very light yellow or greenish yellow in color. After chlorine undergoes reduction by receiving electrons, it will make the bromide ion release electrons to form bromine molecule. the color of the solution formed after the reaction has occurred is brown solution. It is said that the observation in this reaction is colorless solution, which is potassium bromide, has turned to brown because bromine molecule has been formed. To ensure or to confirm the presence of bromine molecule, we add the confirmatory test. The confirmatory test is using 1,1,1 trichloromethane. When added with this organic solvent, bromine water will form orange or brown layer at the bottom of the test tube. This confirms the presence of bromine molecule. Let us see what is actually occur during the reaction. As I've mentioned before, the bromide ion in potassium bromide has been releasing electrons to form bromine molecule. Bromide ion undergoes oxidation, and bromide ion is a reducing agent, while chlorine molecule receives electrons and undergoes reduction. Chlorine molecule is said to be an oxidizing agent. Now we need to form the full ionic equation for this reaction. The oxidation half equation stated that two bromide ion release electron to form bromine molecule, while reduction half equation says that chlorine molecule receive 2 electrons to form 2 chloride ion. Both half equation consist of same number or same amount of electrons. Therefore, we can cancel out the electron and combine both half equation to get the full ionic equation. So the full ionic equation is 2 bromide ion plus 1 chlorine molecules to form 1 bromine molecule and 2 chloride ion. Let us discuss about the observations and corresponding inference for these reactions. In these reactions, the color of potassium bromide, which is KBr, changes from colorless to brown. It is a better answer if we don't write the name of the substance. So we just mention the colorless solution turns to brown. Okay, why does this observation occur? Because bromine is formed, or bromide ion release electrons to form bromine molecule, or bromide ion is oxidized. The second observation is the color of chlorine water changes from greenish yellow to colorless. Practically, we cannot see the changes of color in chlorine water, because bear in mind that chlorine water added into the solution is too small amount, only a few drops. But theoretically, this is the observation that we will get. Why does the greenish yellow chlorine water turns to colorless because chlorine molecules accept electrons to form chloride ion. I've mentioned before that the color of halide ion is colorless. It is also said that chlorine molecule is reduced. In the discussion in previous slide, I have mentioned how to confirm the presence of halogen. We will need to add 1,1,1-trichloromethane as an indicator to detect the presence of halogen. In this diagram, I have included the color of halogen in water, which is chlorine. It is greenish yellow or very pale yellow, while bromine, it is orange or brown according to the concentration of the bromine. Iodine, the color is brown. But if we add 1,1,1-trichloromethane into the halogen, chlorine mixed with 1,1,1-trichloromethane will produce almost colorless color or very pale yellow, while bromine in 1,1,1-trichloromethane will show the very bright brown color or orange in color, while iodine in 1,1,1-trichloromethane will form purple layer at the bottom of the test tube. This different color in 1,1,1-trichloromethane can help us to identify the presence of halogen molecule. Now, by referring to the diagram of colors of halogen in water and in 1,1,1-trichloromethane here, let us predict whether the reaction occur or not in the table below. The first reactants are bromine, water, and potassium chloride. Because bromine is less reactive than chlorine in the series of halogen, therefore this reaction won't occur. Because the reaction doesn't occur, it is said to be there are no observable changes. But if we add 1,1,1-trichloromethane, this organic solvent will detect the presence of halogen. The halogen that remains in this mixture is bromine water. So therefore, the color of bromine water in 1,1,1-trichloromethane is brown or orange. Therefore, we say that the brown color at the bottom layer form, identify or confirm the presence of bromine that hasn't react with potassium chloride. Now we move to the second reactions, which is between chlorine water and potassium bromide. Yes, in this reaction, halogen added into the solution is more reactive halogen. Chlorine water is a better oxidizing agent and will receive the electrons. Therefore, this reaction this displacement reaction will occur. What can be observed during this reaction? Because the reaction occurs, bromide ion in potassium bromide will release electrons and form bromine molecule. Therefore, the color of bromine molecule in water is brown. Therefore, the observation is colorless solution will turn to brown. Because bromide ion has released electrons and form bromine molecule will be detected by 1,1,1-trichloromethane and shows the brown color at the bottom layer. These times, the brown color at the bottom layer detect the presence of bromine molecule that is the product of the displacement reaction. Okay, students, now I need all of you to answer and to fill in this table in order to confirm, to enhance your understanding in this subtopic. The reactants are between bromine water and potassium iodide. Next, between chlorine water and potassium iodide. Iodine water and potassium bromide. Iodine water with potassium chloride. Please fill in the table and send it to my Telegram so that I can check your answer. So thank you very much for your attention. See you in the next lesson.